So thank you very much. Um, I think the first part of this presentation is going to be is going to be on the proposed system architecture. It's very important that we do this one. Okay, so talking about the proposed system architecture, what is an architecture? An architectural design is nothing but a kind of it's a diagrammatic representation of the different components, okay, of a particular system. So in this case now, the system we are trying to build is a system that will be able to is a kind of a system that will be able to dictate dementia at their early stage. All right, so talking about the proposed system architecture now, so as you can see on the screen, the proposed system architecture is divided into three major stages. Okay, starting with data preparation, training and evaluation, and of course the last one is testing. So I will start with data preparation. Data preparation has to do with collection of data, okay, pre-processing them, and pre-process this data, okay, and get a kind of numerical representation of this data, okay. And the kind of data that we are actually collecting here, they are brain image data. All right, so that's exactly what we are trying to do. So data preparation now, as you can see, it's also divided into three. It consists of three main subcomponents: data set, data preprocessing, and the output, which is the preprocessed data. So to start with data set now, the data set we are talking about here is just a collection of brain images. So whether demented or not demented, so it's a collection, it's a general a collection of brain images, okay, demented and non-demented brain images. All right, so and that, because the network we are actually constructing does not really understand images, so there's need for us to subject those data sets into what we call pre-processing operations. Okay, so apart from the segmentation, which is core in this particular research, so we did a lot of pre-processing operations, okay, like normalization. And the reason being that if you look at this, some of these images, they are not of the same size. One, they are of different colors, okay. Some are colored and some are not colored. Some are just grayscale. So there's need for us to be able to unify this kind of differences between the images or among the images. So the first thing we did was to normalize, to convert to convert the the color of the images. So what we did was to convert all the images into grayscale, and of course I'll be showing this during the implementation, during the presentation of the implementation. All right, so we did the color conversion, so from color to grayscale, and then we did normalization because the pixel values have different of different numerical representation ranging from 0 to 255. So there's need for us, for more stability during training, there's need for us to standardize or to normalize this. So now we did normalization as part of the processing operation as well. And then of course, we also did what we call segmentation. All right, so then the output of that one, all those data preprocessing operation, is what we refer to as the preprocessed data. So this preprocessed data is nothing but the numerical representation of each of the images in the data set, which cannot be fed into a convolutional neural network, and that's exactly what we did. So that's data preparation. So after the data preparation, we now have a robust numerical representation of this image data, right? So we now pass that, we fed that into a convolutional neural network, and then for training. So we use our data to train, and then during training we have to evaluate until when we get what we actually, our desired performance from the model. All right, so that's exactly what we did. So then after we are done with evaluating the network, the training and evaluation, so the output of that particular stage, which is training and evaluation, is the train model. Okay, so we now have our train model. So with this we can now begin to test on real life data, as we can see on the screen here. So we got an image, a brain image. We don't know whether it's actually demented or it's not demented. So this is an input image. Now we pass it through the same pre-processing, and of course we pass that into our train model. So the model now, so that the model can now determine whether this particular image is actually demented or not. and not only classifying the image as demented or not demented. What we actually wanted the system to be, the model to be able to do, is to be able to tell us, okay, this image is demented, and the stage at which the dementia in the image is currently. And of course, as you can see on the screen now, having processed the image, we pass it through our train model, and the model is able to tell us that, okay, this is a demented image, and the stage at which the dementia is in the image is mild. So that's exactly what the proposed system architecture is all about. I think that one is clear. So to summarize, the proposed system architecture for early detection of dementia is divided into three stages or phases. Okay, the first phase is data preparation, which involves gathering the data, and of course our data was collected from Kaggle, and when we process that, part of the processing operation was segmentation, which is core, and then data normalization, conversion, and so on and so forth. And then the output of that pre-processing is called the pre-processed data, and that is all about data preparation. And then moving on to training and evaluation, which is the stage 2 or phase 2 now. Okay, in the system architecture, this one contains only the training part and the evaluation part. So then in the training phase, after we have designed our convolutional neural network architecture, we pass the preprocessed data into the architecture. We evaluated it after we have gotten our performance, the level of performance that we actually wanted, and then the output of that is what we refer to as the train model, and we subjected that to real life. We tested that with a real life image of demented image, and of course the classification of the prediction is mild here. So that's all to the proposed system architecture. Then this will be elucidated upon better during our implementation. Thank you.